Let me start with a disclaimer. I'm about to make some edgy jokes and puns. Bear with me, because I'm on the edge of publishing a new episode with someone who has an edge over most on a cutting edge domain that we all refer to as the edge. I'm sure you'll be on the edge of your seat when listening to Pete Bernard's take on how the edge can help us take the edge off AI's impact on the environment, among other things. So that's on the next edgy episode of the IoT Show. Hi everyone, this is the IoT Show. I'm Olivier. We have Pete today to discuss edge. So Pete, before we get into that topic, who's Pete Bernard?
Yeah.
Who are you?
So, well, I spent 18 years at Microsoft. I spent 14 years in Silicon Valley. I've been involved with, I would say, kind of edge projects for pretty much my whole career. So I started doing things like, I started as a BIOS engineer, actually, at Phoenix Technologies. So if anyone knows, when you boot up the PC, you get that little prompt thing. So I did that. I actually worked at Phoenix for like 9 years out of college. So that was a long one in Boston. And then I went to Silicon Valley, worked there, did a startup, did a few other things, embedded Java on phones and handsets, got to Microsoft, worked on phone stuff, embedded stuff, edge stuff, Zune, Kin, all kinds of weird stuff that had chips in it and software and connected to a cloud. And then spent past few years working in the Azure Edge group, running the technology partnerships. And then the past kind of 6 to 9 months, been running this thing called Edge Celsior, which is my technology practice around industry analysis, content creation, and strategy consulting.
Okay, fantastic. So I'm just scratching and digging into the Keen and the Zune and so on. But no, let's not go there. Let's not go there. So suffice to say, you have an experience, and we were talking with Rob Tiffany on an earlier episode about what it takes to become an IoT expert, and it comes down to various experiences in various domains at the various stacks of what IoT is about. So, the name in your consulting firm is Edge Celsior. The name there contains edge, and we all have people coming from embedded, people coming from the cloud, people from anywhere. They have their own definition of edge. Can you give us your definition so that we have this context while we're discussing
it's I would say edge is kind of it's a relative term, right? So I always say it's depending on where you're standing, that's where the edge is. But it's really talking about, doing compute outside of the public cloud, right? On devices that are connected to the public cloud. So, there has to be a cloud involved, and there are also devices involved and some connectivity. And those devices really constitute what I would say the edge. And that edge could be, it's the kind of the network edge, so that's outside the public cloud, or it could be the on-prem edge of, heavy edge equipment, or it could be the sensor edge, in a farm or agricultural or manufacturing setting. So that's where it starts to get a little bit relative. But that whole collection of stuff could be an automobile that's traveling down the highway. Those are all, what I would consider edge platforms, and all of the semiconductor software connectivity, manageability, orchestration stuff. All that stuff is pretty universal across what I would consider the edge.
Got it. So anything technology that is not on cloud, on premises, maybe not, actually also rack of servers, right? You have this kind of like
rack of servers in the lunchroom,
where you're running
or
stuff next to
in
your factory
a shipping
floor.
container in the parking lot, or whatever your thing is. That could be very much the edge as well.
Yeah. But that's not new, right? Edge has evolved, but it's not a concept, or maybe the name is recent, but it's not a new concept.
I think that one of the things that's changed is that we're now thinking about these things as continuous systems, right? We're thinking about cloud plus edge as a continuous system, a system of workloads, a system of security protocols, a system of orchestration. And that kind of more systemic thinking, I think, is what is helping define what an edge, what the edge part is versus the cloud, right? So, years ago, as you know, we had embedded systems, and you'd kind of, I would call it flash and forget it, stick it out there for 10 years, maybe occasionally update it with a USB stick. Those days are over, mostly. And now we're really talking about
Mhm.
systems that are, almost like contiguous systems that are running from, Cortex M based sensors all the way to a hyperscaler as one system.
Okay, interesting. So to ask you the preamble for that
Mm.
next question is so Edge
Yeah.
has evolved. To me, there's been something that has been kind of in the back as a commodity. It was connectivity. It was a gateway for
Mhm.
connectivity. It was maybe a device, but you don't realize it has some form of intelligence. But Edge is becoming critical in companies and enterprise digital
Mhm.
transformation because they're starting to proactively think about this notion of
Yeah.
edge compute, of dealing with the sensors data at the edge, on premises, as close as possible to analyze this data, to take
Mhm.
action as well with a rapid response time. But can you tell us a bit more about how critical, from your perspective, edge has become, and in which industries you would say it's more
Right.
critical
Well,
than
you
in
touched upon a
others?
couple of the value propositions of edge, right? It can give you low latency, it can give you data sovereignty and privacy, it can give you, cost flexibility, so that you're doing more processing and less kind of pumping bits to someone else and paying them. So it has a lot of interesting value props, and it kind of depends on the industry. Um, Typically we're seeing a lot of kind of edge compute happening in retail. A lot of retail transformations going on. You think about automated checkout systems and security systems and all kinds of inventory tracking in retail. Manufacturing, of course, is getting totally revolutionized in terms of how people are building things and using edge equipment to inspect and automate that. Agriculture is huge. I know you said you're going to have Rob on the show. Rob's a big advocate on what's happening in the agriculture space. Um, and
Yeah.
then, healthcare, you go into the doctor's office and you look around at all the equipment, right, that's now being used and that data needs to be accurate and secure and also connected. So those are the big ones that I see. I mean, you could look at an interesting question is, well, where does edge not matter? And that could be maybe like in a maybe FinOps, financial firms and other things that they're maybe doing more cloud-based transactions and analysis. But anything that's sort of connected
Mhm.
to the real world, like I said, retail, healthcare, agriculture, manufacturing, things like that, that's where edge computing and a systemic approach to edge really makes a difference.
Got it. Yeah, that makes sense. And that's the reason why we're seeing it more and more. I think because that all these elements definitely are in these industries and in the brewer industry, I'd say are more than
Yeah.
relevant. But so now we are established that it's important, it's
Okay.
critical, it's there. What does it take? I mean, what are the main challenges? What is hard?
Mm,
What are the technical hurdles? How do you do edge
right.
correctly? What is Pete's take on that? What
Yes.
do you say customers when they ask you, I don't know how to do edge, or when they're doing something and you just, okay,
Yeah.
here are the three rules
Well, if
how
you
to
go to
do
my
edge
YouTube
correctly?
channel at Edge Celsior, the one video that plays all the time when you get there is it's called Edge is a Team Sport. And it's a little bit of a primer on the complexities of edge. And one of the challenges is that it's inherently a heterogeneous sort of exercise, right? You've got devices from different
Mhm.
manufacturers with different software stacks. Your connectivity could be this or that, and then you're connecting to one or more clouds, right? And so that's one of the big challenges around edge is you have to think about, like, it's a team sport. Who's on your team? What team are you on? What needs to work with what to solve the problem that you're trying to solve. So that's one of the big ones that people need to think about when they think about edge.
Okay. Well, team sport, orchestration, that makes
Yeah, yeah,
sense,
and
right?
orchestration. You
You have
said
to
the
have a
magic
coach.
word, so it's like the what was it? Pee Wee Herman's Playhouse. The magic word of the day is orchestration. So it's like
Yeah.
we think about orchestration as like spinning up VMs and containers in the cloud, but really orchestration is about how do I not only manage my cloud workloads, but how do I manage my edge workloads and where on the edge are those workloads? So think about orchestration across multiple clouds, right? So you've got your hyperscaler, but maybe
Mhm.
you've got your legacy data system and you've got your core weave for AI and you've got your whatever. And then you've got orchestration down from the cloud to the edge. And so how do you take workloads and deploy them on that, Windows IoT box over here and this Linux gateway there and this sensor over here? And so that's the kind of the I think the one of the frontiers right now with edge is like how do I think about orchestration
Yeah.
beyond just the cloud, but using cloud DevOps to go all the way to the edge. And I think that's one of the key
Yeah.
areas. We're seeing a lot of great innovation there from software companies with edge platforms, orchestration platforms, but also the hyperscalers have their own orchestration platforms too. So
Yeah, yeah, yeah. And you were saying that it's an extension of the workloads that are in the cloud, and now you start distributing them and orchestrating them at the edge. But the edge is not always connected. So you also you have this level of complexity to be taken into account when you implement an edge solution or an extension at the edge to your solution that consists in having a continuous orchestration, or that having that system still work when it's offline, right?
Be
Because
connectivity
you're in a cruise
aware or
ship.
is kind of state aware about what's connected when, and not always, right? Especially in some of the, there's a company called Caliper that I love out in Australia. They do a lot of work with railway systems and water systems, and so they're deploying sensors way out there in Australia in the outback. And yeah, you're not always connected. And, you may be connected for certain periods of time or for some maintenance. And so how do you maintain that system, the integrity of that system, and updating it? So, one of the things that distinguishes Edge from kind of previous embedded and IoT things is that everything is manageable and updatable, right? So you can push AI workloads,
Mhm.
new AI models, newly trained models down to a device, as well as kind of firmware updates and bug fixes, as well as getting data back. And so to do that, connectivity is a key part of the strategy. How is it connected? When is it connected? How much does it cost to be connected? Maybe there's multiple ways to be connected depending on what the job is, right? Is it a firmware update, or is it a telemetry dump, or is it something more? So yeah, it's connectivity.
Mhm.
Think about 5G, LPWA, LoRaWAN, the all of the buzzwords. There's lots of different ways to connect these bits other than just dark
Yeah.
fiber.
Yeah. I have another double click on the orchestration part. So the embedded guy in me is thinking, wait a second. So orchestrating workloads across different nodes or across
Yeah.
different machines, right? So this is not something new. It's been done. It's done in the robotics world. It's been done for a
Mhm.
long time. And so now you're seeing this orchestration from the cloud with cloud technology coming to the edge. And how do you think it's gonna work with ROS and
Yeah.
other technology that are about distributing workloads in a
Yeah.
autonomous system
This is the
these
challenge,
days?
is like, how do you marry up sort of Kubernetes style cloud, orchestration with edge, which is, especially from a resource perspective, not necessarily very friendly or capable of running, K8, containers. And that's one of the challenges,
Mhm.
actually. So I actually have a paper coming out on that, but it's like there's K8s, K3s, there's the concept of K0s, there's, micro EJ, there's other folks trying to solve this so that you can have a single DevOps, system to be able to manage these workloads on these kind of disparate edge devices. But yeah, it's kind of to be fixed, but it's definitely moving in that direction. And so you're seeing, things with like 8 gig of RAM and up are becoming, Kubernetes or container capable nodes that look similar to the
Yeah,
cloud. The question is, yeah, when you get below that, it starts to get a little funky, and that's where
yeah,
folks like us come in to help companies figure that out.
totally, totally. Yeah, I just can't wait. So that leads to my next question, which is, what's the next milestone, I would say, for edge in
Yeah.
general? Or what is it that we're looking towards when it comes to edge technologies?
Yeah, well, I mean, I think one of the things I've been thinking about a lot too is kind of how do we manage our resources. So there's, when you think about when you meet with, Fortune 500 and they're trying to solve a problem, they think about cost, but now they're also thinking about energy and water and other environmental resources, and how do we make the best use of those and when solving the problems, right? So, unfortunately, as you may know, when you ask, ChatGPT to write a cat poem, you're burning a lot of
Mhm.
environmental resources. There's a lot of electricity being consumed, a lot of groundwater being used to cool systems for that cat poem. And I think Edge, the idea of distributing some of these workloads to outside the data center, could really help, I think, mitigate some of the challenges we're going to have with finding enough electricity and power and water to run all of the AI workloads that people want to run. So that's kind of a long-term frontier, but I'd like us to get a lot more instrumented and visible in terms of the
Hmm.
power and environmental resource consumptions that are happening with some of these systems out there, so that we know what we're getting
Yeah.
into. Because yeah, the curves aren't really moving in the right direction. I mean, my understanding is at current course and speed, we need like another Earth, basically, to supply the resources that we're
Yeah.
currently
Yeah.
consuming. And so, as we sort of pile on the AI workloads, we just have to be thoughtful about, well, how do we do this in a way that's sustainable?
Agreed. Agreed. I like that. I like what you're, and actually it was following some of the evolution of LLMs and Llama and others. And I'm seeing some experts of the embedded world trying as much as possible to optimize these
Right.
models so that they run on tinier devices. And yeah, at the end of the day, you don't need the whole shebang of a chat GPT to do simple tasks, even if they are smart
Right.
tasks. Like you can specialize them and train your model down to something that can be powered or can be run
Yeah.
on something as tiny as possible locally,
Yeah, I mean,
right?
there's organizations like TinyML and other groups that have been dedicated to figuring out how to squeeze AI models into 10 kilobytes or whatever the thing is. Obviously, you can't squeeze a large language model into 10 kilobytes, but yeah, certainly there's a lot of functions you can do. And as semiconductors get more and more powerful, right, or being manufactured in new processes that use less power, you will be able to do more and more with less and less, resources, which is pretty exciting. And that's cost resources too. So yeah, it's exciting to see. Of course, it's
Mhm.
like, I've got my 10 billion data point model, which is fantastic, but what can you do, under like, 10 watts or 2 watts or whatever, what kind of AI, vision AI or anomaly detection or other things that I can do, at the lower power edge, to complement some of the big stuff, so that you're running the big stuff when you need to. But for other stuff, yeah, you don't need to, ask Chat GPT what's 2 plus 2. I mean, that's kind of ridiculous. So that's kind of happening now. And I
Mhm.
think as we start to get more holistic in these systems with orchestration and these, other things, we'll be able to count on the edge to do more and more of the AI workload.
Like that. I like that. And I like that in many of the hyperscalers conversation around AI, when they talk to me, at least that's where I'm hearing it, when they talk about responsible AI, to me they include being environment friendly and because not just about data and privacy, it's also about using that power, that energy in a
Yeah.
right way and not wasting it and not making more damage
Yeah.
than
Yeah. No, again, if you go to my
necessary.
YouTube channel, there's some videos on that story as well. And it's, now, you have to look at, if I'm a hyperscaler, I want to run all my workloads on my my 64 data centers that I just built around the world. So there's a financial incentive for hyperscalers to run things on the cloud. But as a commercial customer, you want to think about, what's your total bill here for, running your systems. And if you can run some of that stuff on prem and avoid the egress and the fees for hyperscalers, then why not, right?
Yep, I love that. Okay, Pete. So I brought back your name. There was the name of the company, Excelsior. Yep, down there. Yep. And we'll add in the comments links to your YouTube
Yes.
channel that you mentioned a couple of times, as well as your blog, whatever. Because you also mentioned a couple of papers that are
Yes.
coming that I'm looking forward
Edcelsior.com.
to read, and that I'm sure our
Yes,
audience
and I have
will
a
as well.
podcast, The Excelsior Show, of course, and also on
Yeah,
TikTok. So if you're on TikTok and at Excelsior,
yeah. I need to start
yeah,
doing
no,
that.
it's an interesting
You're
space
doing
out
that
there.
well. So
A little different, but yeah, you can find me pretty much anywhere.
people will find you. Thanks, Pete, a
Cool.
lot
Well,
for
thank you.
today. And well, everyone, thanks for tuning
All
in.
right,
See you
thanks.
soon,
Bye
Pete.
bye.